Hi students, now the third numerical problem in the exercise. Calculate the energies of the photons associated with the following radiation. First one is violet light of 413 nanometer and second one is X-rays of 0.1 nanometer and the third is radio waves of 10 meter. It's a very simple question and very direct numerical problem. So the energy of the photon is given by E and V is in the suffix for violet. So this is equal to H C by lambda violet. So this is equal to 6.626 into 10 to the power of minus 34 is the Planck's constant H into 3 into 10 to the power of 8 meters per second velocity of light divided by lambda for violet is 413. So this is 413 nanometer means into 10 power minus 9. So now we are going to multiply using a calculator. So 6.626 into 3, 6.626 multiplied by 3 is equal to 19 point. So this is 19.878 into 10 power here minus 34 and here plus 8. So this is 10 power minus 26. 10 power minus 26 divided by 413 into 10 power minus 9. So this is now equal to, so I am going to divide this number by 413. So it's coming as 0.04. 0.04813 into, now this is 10 power minus 26 and 9 is coming up as plus 9. So 26 minus of minus will become plus. So minus 26 plus 9 is minus 17, minus 17, okay, minus 17. Now this unit is a joule. First we have to find out in joule. Now we have to convert this into electron volt also. So if that, sometimes this may be asked as multiple choice question. In electron volt the choice may be given. So let us practice to convert this joule into electron volt. So this also is equal to 0.04813 into 10 power minus 17. Okay, 10 power minus 17 divided by the charge of the electron is 1.6 into 10 to the power of minus 19. Now the unit will become what? Electron volt. So let us divide this 0.04813 divided by 1.6. So this is by 1.6 is equal to 0.030. Okay, this ratio into, now this 10 power minus 17 divided by 10 power minus 19 comes up as plus 19. 19 minus 17 is into 10 power 2. So the answer is in electron volt. So now the energy of violet radiation is equal to, if you multiply by 10 power 2 means the decimal will shift to 3.0. So this is a 3 electron volt is the answer. This is the first one. Okay, we got the answer as what? 3 electron volt is the energy of the violet radiation. Similarly for X-rays of wavelength now, so here I will use the symbol Ex for the energy of the X radiation. So this is once again equal to what? Hc by lambda. So this is Hc by lambda for what? X-rays. So this is equal to H is 6.626 into 10 to the power of minus 34 into 3 into 10 power 8 divided by lambda for X-rays is given as 0.1 nanometer. So this also can be written as 1 angstrom unit, is it not? Nanometer is 10 power minus 9. So if I will multiply by 10, this will become 1 into 10 to the power of minus 10 meter. That is an angstrom unit. Now you see here, the numerator already 6.626 into 3 into this 10 powers you have multiplied and got the value here. Same value only is going to appear in the numerator, so I will write the same value here. So the numerator is equal to 19.878, okay, into 10 to the power of minus 26 divided by 1. So into this 10 power minus 10 is coming up. So this is 10 power minus 10 is coming up as 10 power plus 10. So this is equal to 19.878 into 10 to the power of minus 16 joule. Now I want to convert this into electron volt. Following the same steps, I have to divide this. So this is equal to 19.878 into 10 to the power of minus 16 divided by the charge of electron. 1.6 into 10 power minus 19. Now the unit is what? Electron volt. So 19.878 divided by 1.6. So this is equal to 12.423. So this is equal to 12.4237. Okay. Into now 10 power 19. It's coming up as 10 power plus 19 minus 16. So into 10 power 3 electron volt. So this is now equal to, you can round this digit as 4 to 4 because 3 is followed by 7. So this is also equal to 12.424 into 1000. So that the energy of the X radiation is equal to 12424 electron volt. 5-digit number. Understand? 12424 electron volt. Similarly, we have to find the energy associated with the radio waves, and its length is more than the other radiation. One radio wave length itself is ranging to up to 10 meter. So here the energy of the radio wave is equal to Hc divided by lambda for radio waves. So this is equal to 6.626 into 10 to the power of minus 34 into 3 into 10 power 8 divided by 10. So this is now equal to, numerator is the same, isn't it? So 19.878 into 10 to the power of minus 26. So that this is divided by 10. So this will become 1.9878 into 10 power minus 26 joule. Just dividing by 10 only now. Now once again, if you divide this by electronic charge, what you will get is what? Electron volt. So this also is equal to 1.9878 into 10 power minus 26 divided by 1.6 into 10 power minus 19. Now the unit will change from joule to electron volt. So I am going to divide this number 1.9878. 1.9878 divided by 1.6. So this number is coming as 1. So this is 1.2424 into 10 power. Now minus 26 is in the numerator. This 19 will come up as plus 19. So that this is 10 power minus 7. Therefore, the energy of a radio wave in electron volt is 1.2424 into 10 to the power of minus 7 electron volt. Okay. So in all these type of problems, first you have to find the energy in joule, and then if you convert it into electron volt, it will be better. Okay. So we are expressing both the joule as well as electron volt by dividing the joule by the charge of the electron. I hope you must have understood well. Fine.